Welcome back, grade 12s. Yep, you know it, back to grade 11 as we revise our trig so we can get ready for this year. I mean, already I'm seeing a 2 theta. I'm thinking of grade 12 stuff and double angles that are coming. But wait, not just yet. Okay, so solve for theta, and we're given that theta is between 0 and 360. So we're just going to be looking for solutions on the Cartesian plane. So I'm just getting a cast diagram ready already. But we may want to do this in terms of general solution and then interpret from there. So it's up to you how you kind of want to do this. I like just going kind of general solution, but let's see when we get to that stage. First bits are sine 2 theta. I'm just going to write it as we're given it here. Sine 2 theta minus 20 degrees equals some sort of magic value. Now, lots of the work was already done for us. It could have been 2 sine and then we had to divide both sides by 2 or something like that. But all we need to do here is say, well, let's use what we colloquially call shift sign to find out what the bit in the bracket here, the argument is. So 2 theta minus 20 degrees, or rather what we can call our reference angle, is shift sign of 0,577. So notice a few things here. I'm not jumping to 2 theta minus 20 yet. I'm just going to call that thing kind of our reference angle for now. And I'm using the positive version of this number we were given. So we punch that into the calculator and we get 35,24. Now we're told that sine is negative, right? Sine of something is negative. So therefore, we must be in one of these two quadrants. So therefore, we're either at 180 plus or we're at 360 minus our reference angle. So therefore, our two solutions are 2 theta minus 20 is either 180 plus the reference angle, because that would be the one option, or, and I like to just leave a gap so that we can work like this, or you can put them left and right of each other. I just don't think I'm going to have enough space. 20 degrees equals, the other one was 360 minus our reference angle. Okay, so therefore we can solve for what theta is. Now it says that the theta is between 0 and 360, so we're only going to get two solutions, but let's see how we get there. So we can add 20 to both sides of our equation. So 2 theta equals 180 plus 35,24 plus 20 degrees. And then we'll need to divide that by 2. So that's 250 and 235,24 degrees. And then we'll need to divide that by 2 to get 117,62 degrees. So there's our one solution, and we could solve our second equation. And we'll do it in the same way. 2 theta equals 360 minus 35,24 would be the other quadrant 4. And we can then add 20 to that, and we'll get 344,76 and divide that by 2. So 172,38 degrees. And those are all our answers. But it's worthwhile just thinking of general solution, even though we're going to do it in the next question. But let's just have a look here at if we were asked what the general solution is. Well, 2 theta minus 20 is 180 plus 35. That's the one option. But if we went round by another 360 degrees, we'd sort of be back where we started. And we'd also get the same answer. So therefore, we could say plus 360 times some sort of integer. Choose your variable. I'm going to choose m today. So m is some integer. In other words, you can add 0 360s, 1 360, 2 of them, minus 4 of them. We're going to get the same answer. So therefore, if we were working out the general solution, we would do that. And then when we divide by 2, we would add 180m because we have to divide the entire equation by 2. And what's quite nice about thinking through this now is, well, sine 2 theta, other things we might be thinking of is, there's sine theta, right? Let's just make, there's sine theta going 180, 360. And if we had sine 2 theta, Well, our period would halve, we'd have twice as many of the oscillation of the sine wave in the same amount of time. In other words, it would be repeating every 180 degrees, which is reinforced by this plus 180. So just other things we can start seeing and thinking about as that sine wave disappears behind me. Okay, so those are things to think about, and we'll do it in the second solution as well. It didn't ask for the general solution, so we can just leave it like that. Now, it said that theta is between 0 and 360. So did we get all the answers for theta between 0 and 360? Well, we got theta's 117, and we said that we could add another 180 and we'd have another solution. So I'm just going to leave that. I was going to leave it as a C, but wait a second, did I don't know how to... Oh, there's my things. So if we added another 180 to 117, would we have another solution between 0 and 360? And the same over here. If we looked at our general solution and said plus 360m, that's still plus 360m, and this would be minus 180m. If we added another 180 to 170, would we have another solution? I think we would. Well, I'll leave that one to you. See you in the next one.